Hello world, this is Rob.
And this is Obi. And this is Roy.
Your laboratory buddies. For today's video, we'll be conducting a test on the compressive strength of cement mortar. This test determines the maximum load a mortar cube can withstand before fracturing under compression. It's a crucial indicator of the mortar's ability to handle compressive forces in masonry structures. So, without further ado, let's get started. Today we have a couple of things we aim to acquire, as with all experiments. Our main objectives are to evaluate the compressive strength of mortar under a compressive load and assess the quality and suitability of the mortar mix for its intended application. Starting the experiment proper, first we gotta gather the things we need. That includes materials and equipment. For materials, we need cement, sand, and some water, which will all be measured as we go through the testing. For equipment, we need a compression testing machine, which applies a gradually increasing compressive load to the mortar specimen. Some standardized cube-shaped molds, which is typically 50 mm cubed to cast the mortar specimens. A mixing ball and trowel for mixing the mortar ingredients. A balance to weigh the cement, sand, and water for accurate proportions. And finally, a tamping rod for compacting the mortar in the molds. After gathering everything we need, let's begin by preparing a mortar mix using specific proportions of cement, standard sand, and water as per the test standard. Next, we thoroughly mix the dry ingredients before adding water. Then, add water to achieve a desired consistency for the mortar. That's usually specified in the standard. We then fill the molds with the fresh mortar and compact it using the tamping rod according to the standard procedure to ensure uniform density. Level and smooth the top surface of the mortar in the molds. Next, we allow the mortar specimens to cure in a moist environment at a specific temperature for a designated period, that is typically 28 days. After curing, we remove the mortar cubes from the molds and place them on the compression testing machine platen. Apply a gradually increasing compressive load to the mortar cube until it fractures. Record the maximum load at which the fracture occurs. This process is repeated 3 times for the 3 samples. If you'd like to try this test, here are the written procedures. Now that we have gathered our data, we shall now head to the computations. The compressive strength is calculated by dividing the maximum recorded load by the cross-sectional area of the mortar cube. We then get the average compressive strength of the whole batch by adding all the results and dividing it by 3. Now, let's compare with the specifications. According to the standards, for every 50 mm cube or 2 inches cube sample, the compressive stress or strength should be around 10.30 MPa to 13.80 MPa. That's megapascals. Here's the data we gathered from our experiment. We got an average load of 27.62 kilonewtons and an average stress of 11.05 MPa or megapascals. This number is within the range of the specifications, therefore it is recommendable for future projects. So why exactly do we need to conduct this test? Well, compressive strength is a critical parameter for ensuring the structural integrity of masonry construction. Mortar also needs to possess sufficient strength to resist compressive loads from the weight of the structure and other imposed forces. This test helps determine if the mortar mix meets the required strength for the intended use, promoting safe and durable construction. Guess that's all for today. Hope you learned a thing or two. If you're interested in more of our experiments, we'll be uploading a few more videos soon. So please, do subscribe and hit the notification bell to stay updated. Till next time!